this stuff, and you'll see it in a second. And this keeps the size of these text things down at the cost of the computation of, at the cost of the computation to compress and decompress when we want to read it, okay? And then I pull the GUIDs out, the ID, which is the GUID, and I pull out the primary key for this thing based on the GUID, and I update this dictionary, okay? So let me run that code. It is doing a lot of cleanup, and I'll tell you, it took me a long time to make this work. So this code that I'm running now, oh, don't forget to take a Python 3, Chuck. So this is going to run every 250. So it did all this pre-caching, so that's how long it takes to do 250. Now there's 60,000 in here. And so this is really busy. The reason it's bouncing back and forth is that every time it makes this journal file, and then does a commit. So you can kind of see that it's busy making journal files and committing, and there's a lot of activity going on here. Just so happens that Adam shows me these files. Okay, so it finished. It took about 3 minutes to finish that, right? And so if we take a look at the size of the files, we will see that the index is much smaller. It's fully normalized. It's still 263 megabytes. It's all compressed. So let's take a look at that in the browser. So it's 200 megabytes, but it loads up a lot faster. There we go. So we have a senders table, right, which is just kind of a many-to-one table. We have a subjects to table, which is a many-to-one table. And we have messages, which has foreign keys. It takes a little bit to load that up. Okay, and so we see the foreign keys for sender and subject, and that saves us. All those foreign keys save us. And so we have, you can kind of see that I can't see the headers in the body because now they're compressed. That saves me a whole bunch of stuff, right? It saved me a whole bunch of stuff. You know, and so that's what's in that file. And that we've finished this process, okay? And we've finished modeling the data and making it really clean, and we'll pick back up, and the rest of the stuff we will do is actually visualizing pulling data out of index.sqlite. The idea is this can be restarted, this can be run over and over and over, even though it takes like 3 minutes to run this. That's way better than 5 hours to run this. So 3 minutes, 5 hours, and then we'll see now reading this is in seconds because we got it all nice and normalized in a quite pretty way. So I hope this has been useful. In the next one, we'll actually do the visualization. We are in the process of retrieving data from this Gmane server, one that I've made a copy of. And we have so far spidered it all. Ended up with 600 megabytes of spidered information. We have ran a rather complex cleanup process that you probably don't need to fully understand. You can look at it for patterns, but in general, the cleanup process will be very sensitive to the data. And then we have this index.sqlite, which is 260 megabytes right now. And we're going to now do the fun, easy bits here, where we're going to run little queries that just pull data out. And so these are much simpler. So part of what I wrote when I was doing this is I wanted to do some simple basic calculations on the data to make sure. I really was sort of looking for anomalies, right? What was working, what wasn't working. So I wrote a series of really simple things like this gbasic. The gbasic code just give me some basic data, right? So I wrote things down and I counted things, and so do I need URL lib request in this one? I don't think so. Let's fix that bug. It's not there. No reason to put any of that stuff in there. So it reads that index.sqlite, which is our cleaned up data. It reads through and makes a dictionary. This pattern you're going to see a lot, where I'm going to make a dictionary of ID to senders, save myself repeatedly looking at things. I'm going to grab the subjects. I've cached them all. I could have done this all with SQL, but I just wanted to do things faster. And now I'm going to go through each of these messages and make a dictionary of them. I'm going to put a lot of stuff in memory, and then I'm going to do some counts. I'm going to see who is sent the most, right? The organizations, and so now I've got to go through the all the messages. I am not actually, so you'll notice that I'm not selecting the body or the headers here. I am just getting sender ID, subject ID. I probably could have done this with a join. It would have been cleaner. You can do that. You can make that change. Do that with a join so it's cleaner. So I'm going through all the messages except not the body, so this is going to be really quick. And I'm pulling out the sender's ID. I'm breaking the sender into pieces. See, my data is clean now. I cleaned it all up in the previous processes. And if I don't have two pieces, I continue and I get the domain name. So I have the person. I'm doing a basic dictionary histogram for the people and the domains. And then I'm going to sort them, right, with a sorted. And we're going to grab the key. We're going to sort it by the how many there are, reverse, and then print out the top few of the organizations and the top few of the people. Okay, so we'll just run that code. Python gbasic.py. Let's dump out the top 10. So we loaded 59,000 messages, 29,000 subjects, and 1,800 senders, and figured out the top 10 people and the top 10 organizations. And you can write various things like that that just sort of scream through your data, and it's good to get sanity checking on your data. Okay, so that's gbasic. Now I want to do gword.py, because that's kind of fun. gword.py. I don't need URLlib. Why do I keep putting URLlib in all these things? So we'll get rid of that. So this is really simple because I'm just going to go for the words in the subject line. And so I go through index.sqlite, I read in all of the subjects, and I make a dictionary of those, and then I go and find all the subjects. And then I'm doing this code right here. I'm pulling out the subject based on the message. And I'm doing this so that when the subjects are used more than once, I count the words more than once. This stir make trans, I talked about that in an earlier chapter. This basically throws away a punctuation in numbers so that when I make my words, I don't end up with words that are like dashes. It compresses them down. Then I strip it, I convert everything to lowercase. This is basically just to keep too many words from showing up. Then I do a split, and then I got a counts, a dictionary. So this is a no punctuation, no numbers dictionary count. And then I just take and do a dictionary, and then I sort them in reverse order. And then I figure out what the highest and lowest is by running through I could have probably done this with a max and a min if I felt like it. And so now I have the highest and the lowest. Yeah, I should have done a max and a min on that one. Why did I do that? But oh well. And now I've got to spread out the size, and so I'm going to produce this file gword.js, which is needed by the visualization because it's going to use d3.js, a word visualizer, and gword.js. I have to tell it how big the text is, and so I'm doing some text normalization. Took me a little experimentation. So if I run this now, and I say Python gword.js, and I say Python 3 gword.js, which is a lot better. Oh, not Python. Okay, so now I can go look at the gword.js, wherever that is, gword.js, yep. And so this is basically, it normalized all the frequencies and made it font size. These are font sizes now. Okay, and so this is just the data that's needed